Okay, this is 4.2.1 using variables to generalize. Go ahead and read through it, underline what you think is important, and then come back to us. This is on page 31 of your toolkit. Okay, so this is what I would have highlighted, and the examples that's being used, it's just one way that we've used variables to generalize, right? So let's go ahead and review what we've learned so far, right? So let's look at variables. Let's go ahead and write this down. Variables, right? These are letters or symbols used to represent one or more numbers, right? So this represents one or more numbers. Okay, and what this means is I can use any letter, right? And I usually shy away from pluses or T's, and I shy away from L's because they look like ones. But usually any letter can represent a number, right? So think of like kind of like a mystery box of something that has a quantity, but you just don't know what it is yet, right? So until then, you just know that it's the mystery box, know that it's the letter, and then when you are told what's inside or what that letter represents, then you can solve, right? And so what this example uses right here, it says we talked about the frames in our lesson, right? So this one says that the square of the right has a side length of 7. We did 10 in class. We did the number 10, right? But this side length is 7, right? This side length is 7. And if I count these 7 boxes for the top and the top, that means that now there's not 7 on each side. Now there's only 5 because I already counted the corners, right? So we've talked about this a little bit. Okay, and then still, right, this is a 7 by 7 frame. It's just that when we actually count tiles, you don't need to double count. So there's this 1, 2, 3, 4, and 5. Right? And then the corners would make 6 and 7, right? And so what they did was they generalized, because in the example, they talk about like a store that people order and you have to know how many tiles will be in the frame, right? So what they did to generalize was, for this one, for the 7, they represent it with X because it's an X by X frame. I don't want to put X times X, right? So this is an X by X frame. This is X, and then the other side is X as well, right? Or 7 by 7 or 10 by 10 or anything like that. But when you find the tiles, it's not going to be 7 on the top and 7 on the sides. It's only 5 on the side, which this right here, sorry, different color. This one right here, the way that you get it is you take 7 minus 2, the 2 corners, right? So there's 1, there's 2, the 2 corners. So what they did right here is they said X, any number, minus 2, minus the 2 corners, right? And that's what we're talking about generalizing. So what they did for this total, for the first one, is they did 7 plus 7 plus 5 plus 5 to find the frames, right? What they do to generalize is, here it is. So this is 7 plus 7, and then this is 5 plus 5. On the other side, they do X plus X, and then X minus 2 and X minus 2, or they combine it. So you're like, okay, well, how many X's do I have? There are 2 X's. This is the top and bottom. And then how many of the X minus 2's do I have? I have 2 of them as well, right? And then they simplify it even more, as in there's 4 X's, and you're subtracting 4. Right? And combining those terms, don't worry about it yet. But if you can get to this space, right? If you can get to this one, that's good. Okay, so two additional ones that they're looking at. The square frame on the left shows another way to count, right? And this is one of the other methods that we looked at, right? But just know that in the end, it's still going to give you the same amount, right? So there's different methods that you can use. So this one they do, instead of the top and bottom, they only do all of it but one corner. That's overlapping. And then they do all of it but one corner right here. And then so there's no double counting of the corners, right? There, and then there is the last one, right? You don't have to color code this, and that's okay, but just know what it's looking at, right? So instead of this was still a 7x7 frame, right? But another way of looking at it, instead of just top and bottom, side and side, now they're just kind of taking the top but not that corner, and then taking the side but not that corner, right? And so this one, how do you get 6? You do 7 minus 1. Minus 1 equals 6, right? So in any situation, the 7, right? In any situation, you would have x minus 1, and that would still give you the same amount, right? So if it was 10 by 10, then you would do 9, 9, 9, 9 on each side. If it was 100 by 100, then you would do 99, 99, 99, 99. And the whole point of this using variables to generalize is that we're making rules, and this is what math does, is you find the patterns, right? You figure out, okay, they subtract 2 on every side. Maybe we can do this for every frame, and then you check it, and if it's correct, then you can use it as a rule every single time. And then you don't have to draw out frames, and then you don't have to draw in your composition notebook, and then you don't have to like actually count out tiles, and it's just a time saver if you can use and create rules for it. Okay, so summary for this one, using variables. Variables just means like X or Y or any letter or symbol that represents a number. And we're just creating rules to make our lives easier. Okay, that's it. Thank you.